Stay strong.
Stay safe.
Stay safe.
Stay safe.
Stay safe, everyone.
Stay together.
Stay hydrated.
Stay
Test.
fresh.
Stay strong, stay safe, stay at home. Stay at home, yeah?
Stay home. くれぐれもお体をお大事に。
Okay, Assalamualaikum. Assalamualaikum. Very good afternoon to everyone. My name is Huda. Thank you so much for being here with us today. I would like to welcome everyone to our special series, Learn with IK Live series, organized by our club by IK Community page on Facebook. IK stands for Integrating Knowledge. We train, we integrate, we help technical professionals across the world to integrate what they've learned into their professional and personal life. This is important because we believe that the correct technical know-how can save life. All it takes is just the push of a wrong button. Neutrality is our priority. Rest assured that we are totally brand neutral with a strict focus on education because we know your next course of decision depends on it. Drawing from decades of experience, our network of industry experts will bring practical wisdom to solution. No textbook, only experience. So I wish you can be part of our club too by just clicking the join button at the page and kindly share this page link to the WhatsApp and Telegram group. Hopefully, we can reach more people who also can get benefit from this series webinar as well. IK will provide an e-certification for those who already registered using Eventbrite link. We will provide a QR code in our thank you email, so just scan the code to get your e-cert. So this e-cert will remain inside the system 2 days after the webinar ends. Before we proceed with our topic, IK Academy would like to invite all of you to one of our first virtual conference, Maintenance X, when strategy crosses digitalization on 26 and 27 October 2021. This conference will bring in 12 experts from 10 countries, which is from Malaysia, Indonesia, Singapore, Philippines, Greece, US, Japan, India, Vietnam, and Mexico, sharing their practical application, strategies that work, and also their digitalization journey. So our speaker today is one of them. Now let's continue with our topic today. You may start to comment and don't forget to put hashtag IK Academy to show your kind support and courage for us. Thank you so much for the response. So the topic today is cutting-edge maintenance management strategies. Choose the right maintenance strategies can helping build the reliability culture for any industry, no matter which industry we are, because strategies will ensure that it has a strong system and meet the entire asset management. Choosing the right maintenance strategy is not always a straightforward process. Assets function in different ways, so it makes sense that each component might need to be handled differently. When deciding on maintenance strategies, the value of equipment and the cost of any failure event also come into play. So we will discuss further for this topic with our speaker today. So I brief a bit about our speaker. With 30 years of solid experience, he had worked in various industries from shipping, woodworking, foundry, cast iron machining, assembly lines, semiconductor manufacturing, and mining industry. Here was where he gained hands-on experience and understanding on both TPM and RCM respectively, a strategy from both the West and the East. He has been invited in different countries and has conducted reliability and maintenance strategy training in UAE, Qatar, India, Malaysia, Indonesia, Brunei, Thailand, Nigeria, Bangladesh, South Africa, China, and Botswana. He has written books on maintenance which are in series, which are World-Class Maintenance Management, the 12 discipline, Maintenance Roadmap to Reliability, Reliability, a shared responsibility for operators and maintenance, cutting-edge maintenance management strategies, problems and solutions on MRO, storeroom and spare part, lubrication tactics for industries made easy. So all this available on Amazon.com. So now let's welcome our speaker today, Mr. Rolly Angeles. Mr. Rolly?
Good morning, Huda, and good morning to our listeners. Okay.
I think now afternoon.
Okay.
Yeah, can.
Good afternoon. Sorry. Good afternoon.
No worries, Mr. Rolly. How are you today, Mr. Rolly? Have your lunch?
Yeah.
Lunch
Finish.
already,
Yeah.
Okay, so I think you may start now. Is it okay?
Yeah, of course. We can start. So, okay, so let me just share my slides with the team, okay? Okay, Huda, is the slide showing up?
Yes, Mr. Rolly.
Okay, so welcome to our short briefer in a movie. It's called the trailer regarding this upcoming training on cutting-edge maintenance management strategies. Okay, so this is what you call a series of the books I wrote. This is the fourth book of that particular series. And if I may be allowed to discuss how everything will start in your industries, so I will assume that the industries come from different variety, different business types, and so on. Now, you may be a manufacturing, you might be producing products, or you might be providing some services to clients, to your clients, okay? But one thing we have in common, one thing majority of industries have in common is that they have assets, okay? Assets, equipment, machines, systems, subsystems, or even a component, okay? So if we try to go back in time since the beginning, okay? So assuming we have an asset, and assuming that we plan to have the asset operate at our plant, then during the beginning, okay, now this asset is designed, okay? So someone designed this asset, and then if the design is approved, then it will be fabricated. Okay, so the OEM, the vendor, okay, will try to get the parts needed for this particular equipment, and they will try to install that. And then after that, if the equipment is completed, then we purchase. Okay, we purchase the equipment. So we have your purchasing people negotiating about the equipment and so on. And once both parties agreed with the purchase, then this equipment will be installed. Okay, it will be installed in your plant, and then this will be the start of the commissioning process. Okay, so it will be commissioned. If there will be some pipes to be installed, electricity, okay, what does this equipment need, facilities, and so on. Then once the commission had been completed, the OEM will talk to us, to operations, to management, or to engineering, to maintenance, and they will tell us that the equipment is now ready to be operated. So they will start to endorse the equipment to us, and this is where we start to operate the equipment. Okay, so we now operate this equipment from day one until today, and in order to preserve, in order to sustain this equipment, now we place and start doing the different strategies on maintenance. Okay, so you have your preventive maintenance, predictive maintenance. So if this equipment contains protective devices which are hidden, so we perform failure finding tasks or functionality inspection, and we can embed what you call the strategy of precision maintenance to be more precise in doing our preventive, predictive maintenance. Now there will be also some tasks which will default to run to fail, or either you have some redundancy in place so that if something has to fail, the system or our operations will not be affected. Okay, so from time to time we have some failures. We perform corrective maintenance. If you're implementing TPM, you have your operators activity addressing the basic equipment condition. Okay, and then the time of the equipment will come to a point in which it has already what you call maximize the life of the equipment. But still, if we consider using this equipment, there is a possibility of what you call extending the life cycle of the equipment by doing some what you call improvements, modifications, or some maintenance prevention design, or root cause failure analysis, or some FMEA. So by doing this, we can extend the life of the equipment. Okay, so until finally it will reach its maximized lifespan, and so we decide to what you call retire the equipment. Okay, so this is the aging process. Either we retire the equipment, or the product had been phased out. So this is the aging. So this is the time we decommission our equipment, meaning this will be the end of life. Okay, so in order to perform our activities as maintenance, we need to first to answer the question, what will be the role that maintenance will play on this equipment? Okay, so we need to understand our role and our objective. And our main objective will be to take care of our equipment's total life cycle at the most reasonable cost. And to do this, the first and the foremost and the most basic needs will be for our maintenance to be educated, okay? So they need to acquire the knowledge they need in order to develop the skills to preserve their equipment, okay? So this knowledge is not just a 1 day, a 1 week. So this is what you call a continuous process for our maintenance people. And once we gain the knowledge, then we can have the know-how to preserve and sustain the reliability of our equipment and assets, okay? So our role is to sustain, to preserve our equipment. And as I have said in my other trainings, seminars, there is no there is no perfect equipment by nature. All equipment have its flaws, okay? So one of the role of maintenance, besides sustaining the equipment, is also to understand their equipment intimately and try to observe those parts or those things that have some design weaknesses, okay, or some inherent problems. And our goal will be to improve them. And once we sustain and improve those items with design weaknesses or with those inherent short lifespan, then definitely the cost of your equipment will be reduced, okay? So it means that our objective, our goal is to sustain. It's not to reduce the cost, okay? Now, if we sustain, if we improve the design of the equipment, then the cost will automatically be reduced. But we cannot prioritize the reduction in cost because the cost can be reduced by so many ways which can be detrimental or which may not be good for the equipment, okay? So our objective will be to ensure the reliability of our equipments, assets, utilities, facilities, system, subsystems at the lowest possible cost under optimal conditions in which it will comply to quality, safety, and to the environment, okay? So this will be what you call the objective of our maintenance, whatever industry you are in, okay? Now, I would like to share something with you, and my thoughts might be different from other speakers, other consultants, or other people, irregardless if I may be in conflict. This is what I believe, and this is what I will continue to believe, okay? Now, if you go and take time to Google, or if you have a dictionary, you try to look for the word maintenance, okay? The word maintenance simply means to preserve, okay? It means to sustain. Now, so if we talk about your equipment, let's say, imagine your equipment right now. So this is your equipment, and let us assume, excuse me, that this axis, this x-axis represents the time, it represents the period, okay? So if our equipment is running, meaning it is loaded, it is it's being operated continuously, there will come a time in which the equipment will fail, okay? So let's assume that during a specific span of period, this is where the equipment will fail, okay? So if we talk about maintenance, these are what you call the activities that are done before an asset or equipment fail. So it means that if we want to preserve our equipment, we want to sustain our equipment, we need to perform different maintenance tasks, and that is to sustain the equipment, okay? So when we talk about maintenance, these are the activities being done, the tasks being done on the equipment to sustain. Now, once the equipment fail, okay, typically we repair the failure, okay? So it means that if we talk about the word repair, this will be the activities that are done after an equipment or machine or an asset fail. So these are the activities done to restore the equipment back to its operating stage, okay, or operating state. So when we talk about maintenance and repair, these are the opposite of both worlds. Now, I cannot agree to the point that maintenance is also repair. These two are opposite, okay? While there may be some speakers, consultants who think that maintenance and repair are the same, they're not. So we need to create this mentality with our common human maintenance resources. Okay? So if we talk about maintenance, now we can transform this into a profit center if we truly understand how to use them correctly. Otherwise, it can be what you call a cost center, okay? If all we do is repair the equipment. And in order to transition, everything will start with its basic foundation, and that is knowledge. So this will be used to build the skills of our maintenance human resources in our plant. Now, we know the situation right now. We have this pandemic and industries are struggling to attend to training because they have some other things to cope up. And sometimes the training is the last priority for our maintenance people. That is why, if you recall in my slide, okay, we upgrade the skills, okay? The skills will come from the knowledge. And training is only one means to acquire the knowledge, okay? So you have books that you can purchase. You have a lot of resources on the internet. You have newsletters. You have videos and so on. So these are what you call the knowledge base that you can use in order to build up the skills of our maintenance, okay? Now, so the question is, if your equipment fail, if it break down, the question to raise is, will this warrant a root cause failure analysis investigation? Meaning, if the machine failed, you have two options, okay? Either you repair or you conduct a root cause failure analysis investigation. Now, if you decide no, then repair. But if you decide to perform a root cause failure analysis, the first thing you need to do is to preserve what you call the evidence, okay? You need to preserve before you repair the equipment. Now, so that's the boundary. And if we talk about WorldClass, meaning a level, perhaps the highest level on the maintenance function, okay? So when we say your maintenance is WorldClass, or the definition of WorldClass, now I would like to borrow the definition from, again, one of the authors on maintenance, which I truly respect, by the name of Terry Wireman. Okay, so he authored several books. One of them is WorldClass Maintenance Management. He said that being WorldClass, it means the ability to compete anywhere in the world, to be able to beat any competitor anywhere in the world with respect to price, product, quality, on-time delivery, cycle time, and so on. Okay? Now, the word world-class maintenance management, okay, means this is the art and science of managing our maintenance resources, which are performed by the top level people, the best in class from industries around the world. But the question is it possible to achieve this level of maintenance, or perhaps the pressure over maintenance? Because I have been in maintenance for a long time, and I know the struggles, I know the pain, I know the adversities, I know the pressure that is happening to many maintenance people worldwide. Okay, so there is pressure on maintenance. Okay, can we handle that, or is the pressure on maintenance the one handling the people on maintenance? Okay, so if we talk about a world-class maintenance management level, okay, now I drafted this in 2008, and this is where I tried to write my experience and come up with a structure on what does world-class maintenance management mean. Okay, so I tried to write several disciplines that must be included in a world-class management structure or world-class maintenance management level. And these disciplines are divided into 3 groups. Okay, so we have what you call the basics, and then we have what the intermediate discipline, which are the different strategies, and we have the more advanced discipline on maintenance. Now, there are 5 basic disciplines on maintenance, which are addressing the basic equipment condition, having a partnership with our operators. So this is about autonomous maintenance. So by creating a partnership, both operator and maintenance can address what you call the basic equipment condition. Okay, so we have a continuous program, assessment, training needs regarding the skills of both our operators and maintenance. And one of the basic that you need is your KPI. What do you think is important in maintenance that you need to measure, okay, on a consistent level and monitor? So, and the last will be how to optimize our preventive maintenance. Now, once we have the basics, once the basics are in place, then we can deploy the different strategies of maintenance. Now we have our MRO spare parts, we can optimize that one, and we can have a better management on all our lubrication practices, whether you are applying grease or a lubricating oil. And you also have the study of life cycle management. So most especially to those parts that have some design weaknesses, or how you can prolong the lifespan of your equipment. Okay, and another strategy on maintenance will be our people should know how to conduct what you call a root cause failure analysis. Okay, because being a maintenance is not being how fast you repair the failure, but it is all about how you were able to analyze the failure so that we can prevent a recurrence of the same cause of the problem. Okay, and then finally you have your reliability and continuous improvements. So if you're implementing any continuous improvements such as Kaizen, total productive maintenance, reliability-centered maintenance, streamlined RCM approach. So this is part of our continuous improvement. And once we have the basics and we have what you call the intermediate discipline, then finally we can move on with the more advanced disciplines. And this is about strengthening your condition-based maintenance And finally, we automate everything. And that is about your computerized maintenance management software or your enterprise asset management, whatever your industry is using. Okay. Now, if we look at this on another perspective, if we look at the disciplines in another perspective, it's just like building a house, meaning if you try to build a house, the first thing we need to do is build the foundation for our maintenance people, okay? So we have the training, we have the knowledge base where we develop our skills. So educating maintenance is very, very important, okay? And sometimes I think that what we need is not experience, what we need is knowledge, okay? The two are very different. Because by having the correct knowledge on maintenance, we can develop the correct culture we have on maintenance, the values of our people, the belief. This is where we write our policies, and this is where we set our goals. Okay? So once the foundation had been laid down, the key people in your organization, engineering department, reliability people, maintenance people, I think they need to sit down, okay? Have a cup of coffee, sit down, decide what are the important key performance indicators, measurement, metrics, or yardstick that we need to measure, okay? Now, it is like a personal goal. You want, you're chubby, you're fat, you want to trim yourself, okay? So before doing the exercise, before going on a diet, the first thing we need to do is weigh ourselves on a weighing scale, okay? So once we have the metrics, then we talk with our operators and create what you call a partnership, okay? So instead of having this merry-go-round of blaming, meaning the operators blaming maintenance, the maintenance blaming the operator whenever there is a breakdown, a downtime, why not sit down? Let's talk about that. Let's talk about it. Create a harmonious relationship so that if the operators will agree, then together they can help in establishing what you call the basic machine condition, okay? So meaning when we talk about the basics, now this is just having the complete set of screw, bolts, nuts, fasteners, an equipment with no leak, an equipment with the correct lubrication, okay, and a clean equipment, okay? Now, this is what I see in majority of industries. They will buy the top of the line SKF vibration monitoring from SKF, or they will buy a million ringgit worth of infrared thermography, where the fact lies that their equipment miss one bolt, a couple of bolts, and my God, that one piece of bolt means something on your equipment, okay? So it's not about deriving the top technology or this predictive maintenance, and your equipment is a mess, so nothing will improve, okay? And then we optimize our preventive maintenance. So once we have the basics in place, then it's up to you what you want to prioritize in the strategies. Determine your strength, determine your weakness. If you're weak on spare parts, then let's start from that. Or you want to go for life cycle management, it's up to you, okay? So these are the different strategies we can adopt once the foundation and the basics are in place, okay? So once you have the basics and you have the strategies, then we can now move with the more advanced, which is the condition-based, and finally we automate everything. So now I know my destiny in life, and each of this discipline, I am writing a book. Okay, so I'm not yet complete. Okay, so maybe there are 5 more books that I will write, and this is a supplementary book. And I just completed this one. I'm very excited. This is about a book on root cause failure analysis. Okay, so these are the books I have written. All of them are in series because all of them connects to every discipline on a world-class management level. Okay, so this is about world-class maintenance management. Now, so if you want to know how from your start right now, let's say this is where you are right now, and you want to move up to that level. So how to achieve a world-class maintenance management? Perhaps we can borrow what you call the concept from a great author, Stephen Covey, which is the author of Principle-Centered Leadership, author of 7 Habits, and so on. Now, in his book, Principle-Centered Leadership, we can adopt a 4-step to gauge where you are and how to move to that level. Okay, so the first thing you need to know is to understand where is your maintenance currently right now, where you are right now. From a scale of 1 to 10, where is your maintenance right now? Okay, now you can perform this by conducting an internal assessment. You can assess your situation. Now assuming from a scale of 1 to 10, you are on scale number 2. Okay, so once you know where you are, then the next step is you need to create a plan. Okay, where do your maintenance want to go? Where do you want to go? Okay, so you need to have a vision where you project your maintenance to be after a couple of years, after 4 years, after 5 years, and so on. Okay, now, and also important in this is to be unanimous, to have one direction. Okay, so once you have a direction where you want to go, then now we develop the roadmap, we develop the plan. Okay, so this will answer question number 3. How will we get there? Okay, so you need to draft a plan, review them if it is doable, achievable, or if it is a smart plan. Okay, and finally, once you deploy the plan, once it's been implemented, then we need to measure, okay, our indices so that we know if we have arrived on our destination we want on maintenance. Okay, so question number 1, question number 2 also discuss your indices, your measurements, your KPI. It's like when you're going on diet, okay, you want to reduce some weight. The first thing you need to do, you weigh yourself. Then you create a plan, a roadmap, and then after a period of time, you weigh yourself again. Okay, so this is how it should be done if you want to know where your industry currently right now is standing. Okay, so if we put this to another perspective, because the things I discussed is about world-class maintenance, okay, and this is a briefer or a primer on cutting-edge maintenance management strategy. Okay, so if we ask what are the different cutting-edge maintenance management strategy, the first thing we need to know is to understand our problem, understand our failures. Okay, so if we talk about failure, now there are 3 stages. Now we have infant. Okay, so it means that it happens at the beginning, And mostly you will experience this right after a new equipment had been commissioned, or sometimes you experience this after performing a major preventive maintenance in which the operator is having a difficult time running the equipment. Okay, so if you're experiencing that, it means that your equipment is suffering from infant mortality failures. And then we also have a case of random failure, which is rampant. Okay, so we have several parts, several items in which the dictated life is not reached, it's not being reached. Okay, let's say you buy, you purchase a bearing from SKF and the bearing has a life of L10. Okay, so it means that if we talk about the reliability of the bearing, it should be at 90% of 10 years, which is 9 years. Okay, so that is the dictated life calculated by what you call the bearing manufacturer. But when we purchase that bearing, we install that in our equipment, it doesn't last 9 years. It lasts 3 months, 6 months. Perhaps we're lucky if it lasts a couple of years and so on. So it means that if the part doesn't reach its natural lifespan, we have a case of random failure. Okay, and these are prevalent, and this is mostly our problem. And every time a breakdown happens, we're surprised by that, because 99% of the time, the failure is random. Okay, and we have on the other end the age related. So it means that the lifespan of the part have been reached. Meaning, if we say that the life will be at 6 months, it will reach 6 months and then it will fail on that particular period. Okay, so if we look at the failure on a wider angle, we have those failures that are considered infant. We have failures that can fail prematurely, and we have those age-related failure. Okay, so our approach on maintenance is to provide a strategy that will address the 3 types of failure. So for infant mortality, we can adopt a more precise maintenance by adopting precision maintenance. Now, for random failure, some random failures can be predicted. You can use your instruments or condition-based maintenance tools, instruments, and there will be also cases that we decided to just allow it to fail, or if the failure is critical, perhaps we can modify to prolong the lifespan. Okay, and for age-related failure, then we can adopt preventive maintenance. Okay, so we have our routine activities, overhauling, replacement, lubrication, inspection activities. So these are all part of preventive maintenance. Okay, now modification, this one can be used to what you call increase the lifespan of the part, and precision can also be adapted by both predictive and preventive maintenance. Okay, so for run to fail, the next question, if we decide something to fail, the question is, will the consequences be negligible, or do we have a standby or a backup? Okay, so if we have a backup, then we determine the switching frequency. Okay, so the duty will run for how many months, the standby will run for how many months. Now, if we have no backup, then either we modify, or it's up to you if you just want the failure to happen. Okay, so if we modify, it's best if we perform what you call a root cause failure analysis. And functionality inspection or failure finding can be used for what you call our inspection for our protective devices. Okay, so once we have the strategy, the next thing to do is to determine what you call the correct interval. Okay, so the interval should not be too soon or it should not be too late. Okay, so once you have determined your interval, our interval for doing a predictive maintenance or for doing a preventive maintenance or for doing a replacement, doing an overhaul, or what will be the switching interval and so on, then we can now forecast our spare parts. What spares do we need, the requirements, and so on. Okay, and then it's now easy to develop what you call our maintenance strategy. And once we have this in place, we ask, were we able to prevent, predict, prolong, contain, or anticipate the failure before it happened? Now, if we answer yes, then we're good, we're done. Okay, good job. Now, if not, then I think we need to revisit, we need to review, either we modify or it's up to you. Okay, just let it be. And if we look, so this is what you call the cutting edge, but if we look at the whole strategies on cutting edge maintenance, which is a supplementary for being WorldClass, okay? Now, this is on a wider scope, okay? So first, we need the preparatory deployment strategy for maintenance, okay? So once we have a collaboration or we have a partnership with our operators, then we can simultaneously in parallel deploy both operator and maintenance-driven activities. So for our maintenance-driven activities, this will address the infant random age-related failure as we have discussed in the other slides. And for operators, we can implement what you call the 7 steps of autonomous maintenance, which is a part of the TPM pillar. Now, so for infant, we can apply precision, random and age-related, we can also apply precision. Now, there will be failure that can be under the watch of predictive maintenance, and for age-related failure, this will be under the care of preventive maintenance. So we want operators who can, what you call, perform the basic equipment condition in which the equipment is clean, it has the correct lubrication with no leaks whatsoever, okay, complete bolts and screws and everything is contained on the equipment, okay? So once we have this one, then we can manage our spare parts more correctly by dictating the correct interval, okay? So let's say we have a preventive maintenance to be done after a year, then we can what you call discuss the replenishment time of our spare parts, which should be below 1 year, or depending on the lead time of the spare parts. Okay, so once you have your spares and interval in place, then it's now easy to implement reliability centered maintenance, which can maximize the life cycle of your equipment. Okay, so now once everything is placed, then we can move to digitalization, smart sensors, or integrate technology in our equipment. Okay, but I will not recommend to go for digitalization if your equipment does not contain the basics. Okay, now you will be having a problem, and I don't want you to experience what I experienced. Okay, so this is the holistic concept of cutting edge maintenance management strategy, which is supplementary in implementing the 12 disciplines on WorldClass maintenance management. Okay, and Now, one of the questions raised to me, Huda, is it okay? I just read your questions because this is already continuous.
Sure, Mr. Rolly.
Yeah.
Or you want me to read the
No,
question?
I already answered question number 1 and 2. Okay, you can read question number 3.
Okay. I think no problem, Mr. Rolly. You can continue. You just continue.
Okay, so one of the things raised regarding what I should present on this primer on cutting edge is about spare parts. Okay, so best practices on spare parts, and I think all I can say is I think 95% of industries know the problem, okay, on spare parts, but they don't want to provide a solution on their MRO spare parts, okay? Now, if we perform a very simple YY on our spare parts, and I think most industries have a horrible or an appalling story about their storeroom, their spare parts, so many issues, problem. But the problem on our spare parts is like a domino. It has a domino effect. Meaning if you acquire one problem, there will be a series of problems happening, okay? And everything will start with what you call emergency buying. You don't know what parts will fail. So this time the generator failed, you don't have the parts. We resort to emergency buying, and to keep safe, some maintenance squirrel. Okay, well, when you say squirrel, some maintenance people create their own secret hiding places for spare parts. Okay, so the spare parts are kept anywhere, everywhere inside the plant. Okay, just in case we need it. Now, the question is, why do maintenance squirrel the parts? Okay, so it means that you need to get the parts from the storeroom. But the problem is that when we go to the storeroom and request for the part, the storekeeper cannot provide the spare parts for us, even if it is listed on the system. Okay, so if you're the maintenance, you have a downtime, the operator is waiting for you. You went to the storeroom and you request the part, and the storekeeper cannot provide you, and then you told the storekeeper, but you have 3 more quantity on the system, and the storekeeper told you, do not believe everything you see. Okay, and now you need the part, then you will go for emergency buying. Okay, so when we buy on an emergency basis, we will not only buy 1, we will buy 2, 3, 4. Why? Because we believe in the concept of JIC. What is JIC? Just in case. Okay, so the parts arrive, then we install 1 part, the 3 remaining we keep in our squirrel stores. And at the same time, we already lost our confidence on the storeroom people. Okay, so why do maintenance squirrel parts? Because there are a large number of emergency buying happening, because we have a lot of breakdown. Okay, and if we ask, why do we have a lot of emergency buying? Because there are a lot of stock out. Okay, when we say a stock out, this means either the inventory replenished to 0 becomes 0, or the storekeeper simply cannot provide you the part because it's already gone or out of stock. So if you went to the storeroom, you request for the part, and the storekeeper cannot provide you, then we experience the stock out. So if you experience 1, 2, 3 stock out, definitely you will lose your trust on your storekeeper and the storeroom. So the next question is, why is there a lot of stockouts? When we say we have a lot of stockout, it means that the physical inventory and the system inventory do not match. So let's say physically, we go to the storeroom, we open one drawer. There are 6 bearings with part number BRG1234J. Okay, so if we count the number of bearings in that particular location, we count them to be 12. Okay, we count them to be 12, but the system says it is 20, still 20. Or we look for one item, there is no more inventory, but in the system, it says that you have 5 more inventory. So it means that physically, inside the storeroom, and whatever reflects on the system, whatever software you're using, Oracle or Maximo, now it do not match. It do not match. Okay, and if we ask, why does the system and system inventory and physical inventory do not match? It is because maintenance can access the storeroom during the peak hours. Okay, and it means that the maintenance can go anytime, or the key is on the guard, the security guard, or the supervisor. The supervisor is holding the key to the storeroom. And if we ask, why can maintenance access the storeroom during peak hours? Okay. The problem is, in most cases, the storekeeper is from 8 to 5, but our operations is 24 hours. Okay. So if we ask, why is the storekeeper from 8 to 5 while your operations is 24 hours? Because the top management, the decision makers think that they are saving money by just hiring one person from the storeroom, which is from what you call 8 to 5. Now, this is like, let's say you're in Thailand right now listening, or you're from Malaysia. You have some 7-Eleven convenience store, and the 7-Eleven is open 24 hours, and the cashier and you have a crew of 24 hours. Okay, now just imagine franchising. You want to franchise a 7-Eleven, and then you will follow industry to acquire a storekeeper just one shift from 8 to 5. Now, will you trust the people going inside when there's no one, when there's no storekeeper? It just tell you, guys, I'm home, so if you need anything, here's the key. Okay, get anything. Just don't forget to fill up what you call the withdrawal slip. Now, in my book, I have written on MRO storeroom. The golden rule on MRO storeroom is to trust no one. Trust nobody. Okay? Now, if you trust anyone, then your physical system inventory will not match. Now, so if we ask, why does the decision makers think that they are saving money by just hiring one shift for the storeroom? Now, I think the question here is very deep. I can no longer answer this question, but I can refer you to the Christian Bible, 1 Timothy chapter 6, verse 10, for the love of money is the root of all evil. Okay? Now, one simple problem. Now, if your storeroom is from 8 to 5, and your operations is 24 hours, I cannot help you. You will have a domino of problems. Okay? So if you want the best strategy on your storeroom, it means that you need to deploy what you call 2 sets of strategies. Okay? It means that if you want to have the best storeroom for industries, the strategy should be twofold. Okay, so we can discuss about the lead time. We can reduce the lead time. There are strategies for economic order quantity. There are strategies to what you call, to know the right time to replenish and how to improve the storeroom. That is only about improving the inside of your warehouse. But if you want to really to improve your storeroom, the strategy should be twofold. One to be done inside and one to be done outside. And this is where the maintenance people, reliability people, the lubrication team, the engineering team will work together to provide the 12 disciplines. Now, the concept is very simple. The lesser downtime, the lesser breakdown, then the lesser the spare parts. You cannot just do it alone inside your warehouse, okay? By applying EOQ, by applying how to shorten the lead time. Now, even if you adapt all these kinds of things, but if your production contains a lot of breakdowns, then nothing will change. Okay, it's as simple as that. Okay, so this is about storeroom. And another question that pops up is regarding this cutting edge maintenance management strategy, because one of the disciplines, or one of the things, strategies discussed in cutting edge is about operators. Okay, and why are operators important? Why is autonomous maintenance important? Now, two things. Now, when something failed, okay, what happens is the operator will write a job order, a work order, and then submit that to the maintenance and so on. Now, what am I saying here? Now, what I'm telling is that operators are important, first, because we believe that operators will be the first line of defense on any failure that can occur or happen in our equipment. Why? Because these are the people closest to our equipment during the time of the failure. Now, remember, when something fails, the maintenance will come once the work order, job order is there. So it means that the operator will be the one who will experience the failure. Okay? They will be the one to come face to face with the failure, experience them, and so on. That is why it is important for operator to be taught by maintenance the symptoms of the failure. Okay? Now, they're the ones who will experience the failure, not maintenance. And second, sometimes we are trapped in a reactive mode in which all we do all day is address problem, attend meetings, too much meeting about the breakdown. And sometimes we complain a lot that when you go to your plant, you have an emergency meeting, and then another meeting, and then we have a near miss. So there was a safety meeting from 1 to 2. And then when you look at your watch, it's already 8 p.m. and all we done is either to repair failure or attend a meeting. Okay, so we consume. Now, I recall when I was teaching here in the Philippines, there was a couple of guys who attended, and during the breakdown, they approached me and told me, Rolly, I would like to ask some advice if what we are doing in maintenance is the right thing. And I said, what are you doing in the maintenance? Now, they told me that when you arrive for your ship, let's say your ship is, let's say you are from A ship, okay? A ship, maybe 6 to 12, something, 6 to 12 or 6 to 2, something like that. When you report for your ship, you need to get a form, okay? And they will try to monitor you every hour, Okay, so from 6 to 7, you need to write what you did. And then 7 to 8, you also write what you did, and so on, until you finish your shift. Every day, that is what they do. So they are asking me if that is a good thing or not, okay? And I told them, I told the guys that, okay, let's see a situation here. Now, assuming I'm your supervisor and you submit that form to me, and you submit, let's say, a 10-page, because from 6 to 7, you repair 5 machine, from 7 to 8, and then you have a long list of things to do every hour. You're so busy during your shift for that particular day, in which you try to write down around 10 pages. And one guy submit a form, and when I read the form, I can only read his name. So his name is Mr. Bean, okay? So Mr. Bean had nothing to write, because nothing went wrong with this equipment, with this line. Now, if you make a judgment, who did better, who performed better, I think Mr. Bean performed better. Okay? That is why the challenge is maintenance is not measured by how fast you repair, but how we were able to analyze and address the failure. Okay? If not, then the failure goes back. It recurs, it resurfaces once again. And maintenance can only advance on any continuous improvement effort or improvements if operator accept the responsibility that they should play a major part in maintenance, which is to establish the basic equipment condition. And I have heard so many times that if you have a breakdown, let's say you have a breakdown, okay, then the maintenance you try to repair, and then another machine breakdown in which the operator is calling you, and then another machine, a third operator also failed, is calling you, and you're the only technician or maintenance in that ship. Sometimes what is in our minds is that I think we lack maintenance people. I hope to God that the maintenance manager can add additional maintenance people. Actually, we are not undermanned. That is only a primitive mindset. The problem is that our operators are not helping us, because what I believe, and this is my third book, in which I wrote, the title of the book is that reliability is simply a shared responsibility for both operators and the maintenance people. Okay? But creating a partnership will not happen immediately. Okay? It means that this will be tough at the beginning, because expect resistance. Okay? So when you try to create a partnership, but what is important is we talk, we communicate, we coach our operator day in, day out. Okay? So meaning if you have a repair, if you have an ongoing repair, ask the operator to help. Ask the operator to help. So when the operator is helping you, then communicate with the operator. Tell her what's the problem, what's the part affected, what's the name of the part, and these kinds of things to create a harmonious relationship. That will be the start of creating what you call a partnership. Okay? Now, I also wrote in that book that maintenance cannot escape the vicious cycle of being reactive. You will be trapped forever in a reactive world if the operator will not accept the shared responsibility. Meaning, we can only escape being reactive in our operations if the operator will help us create a bonding, a partnership, and accept the responsibility that maintenance is a shared responsibility. Okay? Now, if you own a car, if you have a car, my question to you, good people listening from Thailand, Malaysia, Indonesia, my question to you is very simple. Okay? Who check if your tire is inflated? Okay? Now, who check if your temperature is increasing while you're driving? Who check if you have enough oil or on your engine? Who check if you have enough water on your windshield? Now, who check if you still have fuel? Now, who check these kinds of things? Is it the mechanic? Now, I don't think so. It's the driver. So why can't we do that on our equipment? It's as simple as that. Okay, and so if we ask ourselves, okay, how to begin a reliability or a direction in our maintenance or our journey on achieving what you call a sustainable asset in our plant, okay, how do we begin a reliability strategy? Okay, now, first we develop a preparatory stage or preparatory phase, okay, and after we complete the preparation, then we go for phase one. And phase one is about restoration, okay? We restore those that are left unattended, those that are being neglected, we restore, okay? Now, once we complete the restoration process, then we move to phase two and try to observe what are the parts that that needs to be improved. Maybe it has a design weakness or it has an inherent short lifespan, and we redesign or we modify in order to lengthen the lifespan. Okay, so once phase one had been completed, expect around a minimum 60% reduction in your breakdown. Okay, so once you move to phase two, you complete phase two, then expect maybe a 80-90% reduction in your breakdown. And once phase one and phase two had been done, we need to create what you call a sustaining process. And this is where phase three will come in. So we need to sustain what we have done in phase one, what we have done in phase two, okay, and finally achieve and optimize our predictive maintenance. And this is where we can integrate reliability-centered maintenance on these following phases, okay? Now, I will be one of the speakers in Maintenance X. And my topic is why do most RCM practitioners, or why there are so many failures in RCM? Now, the answer is very simple, okay? They implement RCM, they implement a sustaining process, but they do not preserve the basic equipment condition. They do not address the small things, okay? Now, the small things matter most. Now, whether this is a lesson in life, or whether this is a feud between our family, or maybe you and your wife, husband are not talking for a couple of days, everything started small, okay? Everything started small. Now, failures started small, but the problem is we neglect them, okay? So meaning you have a small problem, it happened, you have one missing bolt, it happened. Now, the machine can still provide the primary function, deliver the goods, provide the services, and so on. And then a small problem happened, and then another small problem, and then finally it accumulates in which the equipment can no longer tolerate, then it break down. So when it fail, when it stop, when we experience a downtime, this is where we react. But we do not react on the small things, okay? We do not react on the small things. Take care of the small things. It will take care of the bigger problems. It's as simple as that, okay? So if I place this on another perspective, the preparatory phase, or let's call this phase 0, is gather your key people, talk about what you want in maintenance, your vision, your mission, set the goals, okay? Set the goals, then after that, you create an inventory. How many assets, machine, equipment, system, component, subsystems you have in your production, in your area of responsibility, in your plant, okay? And then we create a ranking. Okay, let's say rank A or rank 1 will be the worst equipment. It's a problematic equipment. Rank B, this is not good, not bad. It's in between. Rank C, let's call them good equipment. So for rank C, we just sustain them. Whatever current preventive maintenance, we just do that. Okay. So once you have your inventory, you have a ranking. Let's say you have 1,000 equipments in your industry. So let's say 300 machines are categorized as rank A, the worst. Rank B, let's say 200, and rank C, 500 machine for a total of 1,000. Then we focus on the 300 worst or rank A machine. Okay. So out of the 300, we select one, the worst. So we call that the pilot, and then we set up a team to perform restoration. But before we restore the pilot equipment, okay, now try to get the indices for that particular equipment, the breakdowns, number of downtime, MTBF, the cost of doing maintenance, and so on. So after we restore, we measure that again. So if the indices improve, then we go for the next equipment, okay? So also identify the training your people needs. Now, once the preparation had been done, then we move to phase 1, which is starting the restoration. We start on your pilot. So what we want is to establish the basic equipment condition. Now, when we talk about the basic equipment condition, try to imagine your equipment when it was being installed or commissioned in your plant. What does it look like? Can you still smell the paint? Okay. And so this was what your equipment looked like 10 years ago. And then look at your equipment today. Right now, this is what your machine asset equipment look like. You can see the difference. Okay. So when we say a restoration, we just want to bring the equipment back to its original condition when it was newly purchased, okay? And then we develop, once restoration had been performed, then we deploy the improvement teams, okay? They perform a root cause, they perform FMEA or whatever problem-solving tools. Our goal, or the goal of the phase 2, is to observe the machine, locate the weaknesses, and challenge the team to improve the design weakness of the equipment. Okay. Now, we can also deploy, if you have extra people, we can deploy a secondary team so that we can initiate this much faster, and we will call the team the sustaining or the RCM team. So these two can be a separate team so the deployment can be much faster, okay? So the goal of the RCM team will be to sustain those activities on the restoration and those that are that has design weaknesses, okay, so that you can achieve the goals you want in maintenance. So this is a holistic view on how to deploy a reliability strategy in your industry. Okay, so I think that's all about that, Huda. That's my presentation, and I hope you have listened. And these are the books I have written, and I'm still continue writing. And if you're interested, now in Amazon, you can purchase either the Kindle, a paper, or a hard copy. Okay, but this link is for all the digital books. So it just costs $9.99 US. How much is that? Maybe 10 ringgit, something like that. Okay, so I think that's that ends my presentation, Huda.
Okay.
By the way, guys, if you want a copy of this presentation, you just ask IK Knowledge. I'm happy to provide you this presentation. That's all. Let me just unshare. Okay, back to you, Huda.
Thank you so much, Mr. Rolly. So I believe there are a lot of knowledge and sharing information from Mr. Rolly just now. We really appreciate that, Mr. Rolly. Actually, we do have Q&A session as usual, but since we're already over the time, I think we try to take 2 questions. Is it okay, Mr. Rolly?
Yeah, it's okay. It's okay. We got the time.
But before we go to the Q&A, I would like to share that IK Academy will have a 2-day session for the same topic as today, but with more in-depth and full module for cutting-edge maintenance management strategies on 21st and 22nd October 2021, with special offer for all of our live webinar audience. Okay, so the rest of the module will be life cycle management, reliability strategy development, preventive maintenance, precision maintenance, MRO and spare part management, integrating RCM into the PM methodology, EAM, CMMS, and IIoT. So we have put a link at the comment section. For those who are interested, please kindly click the link and fill in. Our team will contact you to provide any further assistance that you need, okay, if any. So I take 2 questions on the end, Mr. Rolly. We try to end by 4:30. So the first question, how to sustain cutting edge maintenance?
How to sustain? I think the best thing to do is to build this, what you call as a system. Okay, so if you are going for a reliability improvement, a maintenance improvement, now I think it's best if this will be a top-down approach. Okay, so once it's a top-down approach, the head says, okay, we go for it, then we can build this as part of our system by developing the correct policy procedures. Then whoever is doing that, it can be sustained once it's part of the system.
Okay, so I go to the next question. What are the main difference in maintenance practice between East and West?
Yeah, okay, no disrespect to the East, the West, okay, but the way I see it, if we talk about the strategies of the East, okay, they want to address the small things first, okay. So when you talk about Kaizen, the word Kaizen, it means a good. Kai means change. Zen means good, meaning it's something for the good, but only small improvement. Okay, so the E's are fond of very, very small but incremental and continuous. But if we talk about the West people, now they discuss about technology, they discuss about innovation, they discuss about different strategies on maintenance. So I'm not saying that the West is better, that the East is better. What I'm suggesting is, I think before we go with technology, let's follow the East and start with the small things, because later on these small problems will become bigger and bigger. Okay, so I think that's the main difference. And also one thing I'd like to add is I have several books here, which are about strategies from the East. And if the author is Japanese, let's say Nakahima, Suzuki, or Kaneda, I cannot locate, or see the word random. They do not accept, meaning they do not know, or perhaps they do not accept a random failure. The term they use is accelerated deterioration. So meaning you have a life, but the life was not reached. Then you have an accelerated, okay? The problem is random failure is a term coined by the West. So it happens all the time. So meaning, let's just call it random. So that's about it, okay? So I think this is also one thing I noticed different from the East and the West. I'm sorry for extending. I thought I overshoot for 20 minutes.
Okay, Rolly, I know you have a lot to share. So I think we better end until now. Is it okay, Mr. Rolly?
Yeah, of course, because maybe we can have, if there are any questions from the delegates, we can maybe answer one or two of them.
I wish I can do that, but I think we already over the time.
Okay. So, yeah, sure.
So I'm so sorry for the rest who asked question, but I think Mr. Rodi already explained quite complete in the presentation just now. So I hope if you are able to maybe to watch back, or you can also try to go through the link that have given just now, so that you can join our public session 21st and 22nd October. So I hope all our participant enjoy and learn something benefit from today. So the link still available at the comment section. So just click the link and we will try to keep in touch with you. Thank you so much, Mr. Rolly, for your time.
Thank you.
Thank you, Mr. Rolly.
Yeah,
so
thank
before
you.
we end, please leave some comment and on Facebook, and maybe a thank you note to Mr. Rolly. Then don't forget to also like, follow, join our page on Facebook, LinkedIn, Instagram, Telegram, and join our iClub by IK to get the latest update for our upcoming IK Live webinar series. We'll be having the evening talk with Emmeline, Emmeline at 8:30 p.m. With the topic My Internship Experience with Mr. Afiq Abdul Basir. Okay, do check our page for more details. Thank you so much from me, Huda, from IK Academy. And before you leave, please watch this video from all of us from IK Academy. Have a great day today, and please stay safe. Thank you, Mr. Rolly. Thank you so much.
Thank you. Thank you so much for having me. Okay, bye-bye.
Bye-bye.
Everybody. Hi guys.
Stay strong.
Stay safe.
Stay safe.
Stay safe, everyone. Stay together.
Stay hydrated.
Stay strong. Stay safe. Stay at home.
くれぐれもお体をお大事に。